We are going to use an additional 20mm fork, so we need to make 2 of them. The front wheel commonly uses a 2-cross pattern.
110mm.
Hub axle width.
32.
Drive side to flange.
It's same. 32.
Non-drive side to flange.
Planes 59.
Non-drive side flange diameter.
59.
Drive side flange diameter.
ERD taxi tip rim diameter.
Some rims have effective rim diameter information displayed. However, obtaining ERD information for most rims, including from the retailer or manufacturer's website, is difficult. This method is a measurement technique for cases where ERD rim information is not available. We will use gravity. We begin measuring the inner diameter of the rim from the valve hole. Insert the nipple onto the spoke in the direction of the head. Insert the nipple into the hole. Now mark the section where the nipple protrudes with a marker pen. Use vernier calipers. The measurement is 3.5 millimeters. Measuring the inner diameter of the rim becomes very easy. ERD equals 3.5 by 2 plus inner diameter of the rim at 7 millimeters.
Effective rim diameter.
Please select the spoke lacing pattern.
Select spoke lacing pattern.
36 spokes.
Number of spokes.
Okay, done.
This wheel utilizes the cross pattern, which is the standard method of inserting spokes into the flange by alternating left and right.
First, spoke installation.
Let's begin installing the first spoke pattern. Next, let's check the spoke installation sequence. First, install the spoke from flange side A out to in direction. Install the spokes, jumping 1 hole at a time.
Okay, good. Finish.
Install the initial spoke next to the valve hole, then mark it with tape.
Oops.
Jump 3 holes and install the next spoke. Jump 3 holes and install the second spoke. Jump 3 holes and install the next spoke. Great, let's move on to the next step. Second step, flange. B. Fit the spoke inwards from the outside.
Elbow hole. Instead, here.
Install the next spoke next to the initially installed spoke. Here it is. Take a good look here. Jump one hole at a time on the flange and install the spokes. Install the spokes, jumping 3 holes at a time. Repeat the same pattern for the next spoke. The pattern is complete. Third step, flange B, fit the spoke outward from the inside. Install all the spokes in the empty holes. Lower the spokes to tidy them up. Pass over the spokes. Spoke 1 passes over, non-overlap. Spoke 2 passes under, overlap. Now, rotate the hub with the spokes installed in the opposite direction of the valve hole to create a cross pattern. When the bike wheel spokes cross, the last spoke that meets does not simply pass by, but needs to be overlapped and connected to make a sturdy wheel. Rotate the hub while avoiding the valve hole for easier work. Repeat the 2 cross pattern.
Good. Finish.
Finally, the 5th step is to install the spoke in flange A outward from the inside. Simply insert the spokes into the empty holes. It's very straightforward. That's how it looks in CG. It's exactly the same. Repeat the cross pattern once again.
Cross.
Finally, it's the last spoke. The 2 cross pattern is complete. For modern standard hubs, a through-axle adapter is required. Mount the wheel on a truing stand. Using a spoke wrench, you should be able to determine the start and end of wheel rotation while tightening the nipples. Attach a sticker-like tag to the spoke next to the rim valve hole. To tighten the spoke nipple, turn it clockwise. Tighten all the nipples while leaving a 1 mm spoke thread. Tighten the nipples evenly to increase tension slightly. One revolution is complete. It's tightened to a certain extent. The tension is still barely noticeable. Attaching tags to the spokes helps achieve equal tension. Start the left-right alignment by tightening the nipples. Firstly, we will explain the principle behind adjusting the rim left and right. By tightening the right drive side spoke nipple, the rim will move to the right. Conversely, tightening the left non-drive side spoke nipple will move the rim to the left. It is important to note that over-tightening the left spoke nipple can cause the rim to move too far. Releasing the nipple will cause the rim to move in the opposite direction. In summary, the principle is that the tension power balance of the left and right spokes moves the rim and aligns it to the center. We have reached about 80% of the target tension. Using a dishing tool during the process can save time. Adjust the initial left-right tolerance to less than 1 mm. We have completed the left-right alignment within 1 mm. Now, let's begin the vertical alignment. Secondly, let's take a look at how to align the rim up and down. By tightening the peripheral nipples together, the rim will move towards the hub. To move the rim in small increments, tighten or loosen the nipples at least 360 degrees. Loosening the surrounding nipples together will cause the rim to move away from the hub. Vertical alignment of the rim only works when the left and right spoke tensions are adjusted together. There is almost no tension. It's below 15. It's about 80% of the target tension. We aim to achieve wheel vertical alignment within 0.5 millimeters. Vertical alignment takes a lot of time. Start by tightening the parts that make contact and produce noise. We have reached about 90% of the target tension for a 14-gauge spoke. We recommend a tension of 20 to 25 kg force. Adjust the vertical tolerance to less than 0.5 millimeters. If tightening is not possible, you may need to release the rim in the affected area to allow movement. This high-end rim is perfectly round. There are some points to be aware of with budget rims. The valve hole position and the position where the rim is welded allow tolerances of up to 0.8 millimeters. Now, we will use a dishing tool to inspect the wheel center. When assembling wheels, the center can become slightly misaligned due to errors in the wheel truing stand. To correct this, a tool called a wheel alignment gauge, or centering gauge, is used. First, let's set up the dishing tool on the non-drive side. Attach the gauge securely without any gaps. Now, fix the gauge in place. Move the dishing tool to the opposite position. The measurement shows a gap of about 4 millimeters. To calculate the rim displacement distance, 4 millimeters division by 2 equals 2 millimeters rim displacement distance. Now, we only need to move the rim by 2 millimeters. Adjust the position of the rim by tightening the left nipple once and loosening the opposite nipple once. This will allow the rim to move without changing the tension of the spokes. Before starting the job, label the spokes and check the starting and ending positions to ensure accuracy. Start the inspection again from the beginning. There should be no gap on the drive side, and if the measurement distances on both sides are equal, the rim is perfectly centered. Let's check if it is symmetrical left and right. Take a good look. It's about 1 millimeters. Check the spacing. Here, it's also about 1 millimeters. The measurements show nearly equal spacing. This is the center. It's perfect. Vertical alignment is performed meticulously until reaching the desired position. Let's start the left-right offset alignment again. Once again, align the wheel left and right while reaching 100% of the target tension. Check by hand if the spoke tension is generally consistent. Make adjustments only to spokes that are either too loose or too tight. There are no loose spokes. You can compare it to other bicycles as well. It seems like these spokes are the loosest. If you're building a wheel with 14G spokes, it's good to achieve a tension measurement of around 20 to 25 kg. Excellent. The tension meter shows a measurement exceeding 20 kg. It's sufficient. A strong wheel has been completed. Detach the hub axle adapter. This is an incredibly impressive dual disc brake wheel. Install rim tape. Wheel production is complete. This is Dr.Road signing off for today. Subscriptions, likes, and comments are greatly appreciated as they greatly support video production. Thank you for watching.